It is 2 in the morning, and an excavator has just entered a river. Before sunrise, these trucks will leave carrying something that looks completely ordinary. By the time this sand reaches a construction site, it may be almost impossible to tell whether it came from a licensed mine or was taken illegally during the night. It is mixed into concrete, poured into a foundation, and disappears into the city, which sounds ridiculous, because Earth has no obvious shortage of sand. And yet, humanity uses roughly 50 billion tons of sand and gravel every year. Demand for sand used in buildings alone could rise by up to 45% by 2060. So why are people stealing sand from rivers when entire deserts are full of it? Because concrete is annoyingly picky. Cement is the glue, but sand and gravel provide much of the bulk, and the grains need the right range of sizes to pack together properly. Much dune sand is extremely fine and poorly graded, meaning too many grains are similar in size, so it is usually not a simple drop-in replacement for ordinary construction sand. It can be blended or treated, but first, we need to understand why builders keep returning to rivers. For thousands of years, rivers have been breaking, mixing, and sorting rock fragments for us. As those fragments travel, they collide, break apart, and mix with grains of different sizes. Water does much of this processing naturally, often leaving deposits with a useful mix of grain sizes. So we remove it, load it into trucks, and turn a piece of the river into a road, a bridge, or a tower. But river sand is not spare material, sitting around with nothing to do. It helps shape the channel, support habitats, stabilize banks, and carry sediment toward deltas and coastlines. Remove it faster than the river can replace it, and the bed begins to sink. Banks become unstable, habitats change, and places downstream receive less material. In parts of the Vietnamese Mekong Delta, researchers estimated that around 15.5 million cubic meters of sand was being mined illegally each year. Between 2018 and 2020, that is how illegal sand networks, often called sand mafias, take shape. Suitable sand is valuable, construction demand is enormous, and a truckload can lose its history as soon as it enters the supply chain. Once legal and illegal material are mixed together, tracing the original source becomes much harder. And this is not only a Mekong problem. India's national monitoring guidelines call for geotagged lease boundaries, electronic permits, GPS and RFID tracking, CCTV, weighbridges, and drone surveys. But technology only reveals the violation. Someone still has to stop the vehicle, check the records, and act against the network behind it. And as long as cities want huge amounts of cheap river sand, illegal suppliers have a reason to keep returning. But here is the part that makes the entire system look ridiculous. We take fresh sand from a river, lock it inside concrete, and use the building for a few decades. Then we demolish it, call the rubble waste, and go back to the river for more. The material did not disappear. We just stopped treating it as useful. So the deeper problem is not simply that we need too much sand. It is that construction has mostly worked as a one-way system. Engineers are now trying to change where those grains come from and what counts as usable sand. One option is manufactured sand. Rock is crushed, screened, and graded, instead of relying entirely on rivers to prepare the grains. China has already made this shift at enormous scale. Between 1995 and 2020, natural sand fell from roughly 80% of its supply to around 21% as manufactured sand expanded. It still requires quarrying and energy, but it shows that a major construction industry can reduce its dependence on natural sand. Another option begins inside mines that have already crushed the rock. Some of the leftover material can be processed into what researchers call ore sand. At Vale's Brucutu iron ore mine in Brazil, ore sand reached industrial scale. The company reported a production target of 1 million tons for 2022. That means one mine can produce 2 useful materials, iron ore and construction sand, while less of the crushed rock becomes tailings. The third source is much closer, old cities. Instead of dumping demolished concrete, it can be collected, separated, and crushed into a new material source. Researchers at the University of Tokyo used concrete from a demolished school, carbonated the crushed material using carbon dioxide, then pressed and heated it into new blocks. The resulting blocks were strong enough for houses. The process is still developing, but it turns one demolished building into material for another. Even desert sand may become more useful, not by pretending it behaves like river sand, but by changing the recipe around it. Recent experiments have used carefully designed mixtures and compression casting to produce high-strength concrete containing large amounts of desert sand. None of these is a magical replacement. Manufactured sand still needs quarrying. Ore sand depends on material from mines. Recycled concrete needs careful processing, and desert sand concrete is still developing. Each option has costs, limits, and places where it makes sense. The real solution is not finding one perfect grain, it is building a diversified toolkit, so construction no longer depends on the same vulnerable source. Now, look at a city differently. It is not only a place that consumes resources, it is also an enormous stockpile of resources that we have already extracted. Buildings can be designed to come apart. Old concrete can become aggregate. Waste from one industry can become material for another. For centuries, we built cities by digging into the natural world. The next step is learning to build them from what we have already taken, because the next city may already exist. It is just standing in the wrong shape. And that's a wrap for the Sand Story. If you like this video, hit that like button and subscribe to the channel.